So, welcome everybody. Today's topic we're going to discuss about urinalysis. On urinalysis, we're going to check what should be found or what should not be found in urine. So, in this test, these are diagnostic tests or a laboratory test that is always requested so that you can have or analyze what might be causing the problem in urine or any other organ in the body. So in this we're going to interpret the result and see how the results come out. So on urinalysis we're going to have three aspects. That's we're going to see about the physical appearance of urine. We are going to check about the biochemistry part, where we are going to analyze every parameters. Then lastly, we are going to see about microscopy. To start with, on the physical appearance, we are going to check on the color. On the color, we are going to check whether the urine, the physical appearance of urine, how the urine look like. On the clarity, the urine is clear, or when the urine is cloudy, meaning that there are some particles or constituents in urine. And also if the urine is bloody. If the urine is bloody, we are going to check on that and what might be causative agent or the cause of blood in urine. So physical appearance is a good indicator. For example, when the color of urine changes from clarity to, for example, to cloudy or turbid, that could be presence of, for example, proteins or bacterial infection that gives an indication. Then in case of a bloody urine can be an indicative of either infection in the kidney, or there are some parasitic infection that may cause the presence of urine, parasitic infection that might cause the presence of urine in the presence of blood in urine. So physical appearance is a very indicative feature for the diagnosis of or for the analysis of urine. So when we come to the biochemistry, for example, if we start with the pH, this one is the measure of hydrogen ion concentration. pH can be a very good indicator in the diagnosis or in the analysis of urine. When you are checking the reference or the pH of urine should be between 4.5 to 8.0, such that when you are having something like 5.5 to 6.0, we categorize this as a slight acidic. If, for example, if the urine is acidic, there has to be a reason why that makes it acidic. So, acidic urine can be, for example, can be high intake of protein in our diet. Remember, protein is the building blocks of amino acid, made up of amino acid. So, when protein are broken down into amino acid, and amino acids are also further broken down into ammonia and urea. Amino acid broken down into ammonia and urea. Then urea is released or is eliminated in urine. Urea is always acidic, so the presence of urine or the pH of that urine will definitely be acidic. When we check for the SG, this one is specific gravity, we are mostly interested in or is the indicator or a measure of osmolality. Right, this is the concentration of urine particles or urine stuff, the concentration of stuff in urine or particles in urine. So this one will always check on a reference to the SG of water, that is specific gravity of water, which is always 1.0. So when checking on the specific gravity, for example, if you are having the specific gravity of water, which is 1, and you had some particles, or you have some salt, or you had some sugar in it, then the concentration of that water is going to be high, and the SG is no longer going to be 1. The same applies to urine. Urine does not contain water only. It contains some constituents or some particles of proteins, or can be even sugar. Some salts can also be present. So the reference or the range for SG of urine is between 1.0 is between 1.003 to 1.030. So anything which is above, or if the SG is above the 1.030, that is an indicator. But what does it indicate? 1, it indicates dehydration. Dehydration that can be caused by the presence of glucose in urine, which also indicates diabetic condition. There is also, if you are having the presence of inappropriate or syndrome of inappropriate ADH. If you are having syndrome of inappropriate ADH, ADH is antidiuretic hormone. That one can lead to highly concentrated urine, which will be manifested by increased or high SG. SG lower than 1.003 is an indication of hydration. Next is glucose. Glucose is always small enough to pass through the glomerular filtrate. For example, if you are having our glomerular filtrate, if you are having this is our glomerular, then we have the tubule down there, then we have this one is blood coming, then you have the filtrate here. So on the glomerular filtrate here, we find that glucose will easily penetrate here. But what happens is that glucose are always reabsorbed back into the system. They are always reabsorbed along the tubule. What happens when there is presence of glucose in urine is that, 1, if there is overload or high intake of glucose in our diet, or carbohydrate intake in our diet, you'll find that the filtrate cell will be overwhelmed during filtration of blood air in the glomerulus filtrate. Such that during the reabsorption, you'll find that the cells that are responsible for grabbing this glucose so that they are easily reabsorbed back into the system will be overwhelmed. So you'll find that more of the glucose will not be reabsorbed back, and they will easily be released or will easily be taken by urine. Therefore, that presence will be indicative in urine. 2 can be diabetes. The diabetes, we have diabetes type 1 and type 2. Diabetes, we have type 1 and type 2. Type 1 is insulin dependent. There is no production of insulin. Zero insulin. Type 2, it's non-insulin dependent, meaning that they have insulin in type 2. So in type 1, we'll find that which is the insulin dependent, and there is zero insulin What happens is that the body mechanism always destroys the cells that help in the synthesis of insulin, which are the beta cells of insulin of Langerhans in the pancreas. So when the body mechanism destroys these cells, you find that there will be excess glucose, meaning that there will be no cells to grab this glucose, so that they are always maintained within their metabolic state in the system. Therefore, there will be excess glucose in urine. So the presence of it will be indicated when during the test. The next part we are going to have is the blood. Blood is a very good indicative feature, and it has its significance in the presence of urine. So what happens when there is a presence of blood? Always we don't just refer to the blood itself, but it's a measure of when we are checking blood, we check three aspects. The aspects that we are checking are: one, it has an activity called peroxidase activity. Peroxidase activity measures the indicators such as HB, hemoglobin, then we have myoglobin, then we have erythrocytes. To start with the erythrocytes, generally erythrocytes cells do not pass through the glomerular filtrate. When there is presence of blood in urine, meaning that there could be one, damage in the glomerular filtrate or damage in the tubules, and down along where we are going to have the urethra, and so on. Two, for the hemoglobin and myoglobin, hemoglobin we know that carries oxygen in blood. Then myoglobin carries oxygen in the muscles. What happens for the hemoglobin and the myoglobin is that the presence of these, mostly they are reabsorbed back in the system after filtration. They are reabsorbed. But when there is excess hemoglobin or myoglobin in urine, one, meaning that there could be, for example, someone who undergoes extraneous exercise. When one goes through an extraneous exercise, you'll find that the muscles tend to produce a lot of myoglobin. Or when there is a crash injury, for example, if there is a crash injury, then the body will respond by producing, the muscle will respond by producing a lot of myoglobin, which when along filtration, during filtration or during reabsorption, when the cells are overloaded or more of product or an overload of the myoglobin are produced, then excess of them will be present in urine. Then we have protein. Protein is a good indicator. Protein will indicate a condition. Maybe you can have nephropathy, and most protein, the smallest molecular weight that can easily pass through the glomerular filtrate is 20,000 Dalton, molecular weight of protein, 20,000 Dalton. Such that any protein that is less than 20,000 Dalton can easily pass or can easily be infiltrated through the glomerulus, and most of them are reabsorbed back. Such proteins are like albumin and globin, which are carrier molecules. They are easily reabsorbed back during reabsorption. Larger proteins do not pass, but when there is a presence of protein in urine, that is an indication of a disorder. One which I've said could be an nephropathy. So presence of protein in urine is very, very important. Yeah. Then we have nitrate. Generally, nitrate should never be present in urine. What happens is that, and if nitrate is present in urine, then that one indicates either one, bacterial infection, Bacterial infection, there are some bacteria that can easily activate nitrate into nitrite. They easily oxidizes nitrate into or reduces nitrate into nitrite. So, but not when presence of nitrate, which I've said that is an indication of bacterial infection, which results can result in UTI. Not all bacteria can easily break down or convert nitrate into nitrate. And that does not mean that if the nitrate is negative, then that the patient or the client cannot present with UTI, because not all bacteria convert nitrate into nitrate. But the presence of nitrate in urine indicates that there has to be a bacteria that is responsible in the conversion of nitrate into nitrate. So, presence of nitrate is very important indication of bacterial infection which could result into UTI. We have ketone. Presence of ketone in urine is known as ketonuria. Ketone always is an alternative source of energy. One, the presence of ketone can be indication of diabetes, specifically diabetes type 1, where I have said that in diabetes type 1 there is no insulin. So, meaning that if there is no insulin, then the glucose present are not generated. So it's still responsible on the ketone in the generation of energy. Two, can be presence of ketone can also be an indication where we have starvation of carbohydrate consumption. When diminished carbohydrate consumption you can have presence of ketone in urine. We have leukocytes. Leukocytes are an indication of can be one indication of UTI that can be a cause of bacterial infection. Two, can be an inflammatory response of along the urinary tract. I've said one, UTI infection. Two, inflammatory response. Then the last part we are going to discuss about the bilirubin and urobilinogen. Bilirubin, first of all, is a product of HB when we have red cells broken down. Red blood cells have a lifespan of 120 days. So when the red blood cells die, or they are taken into the spleen where they are broken down into heme and globin. Heme is taken into the liver, in the spleen, yes, not liver but the spleen, where they are going to have during the breakdown of heme, we are going to have bilirubin, direct and indirect. We are going to have direct, which is the conjugated and unconjugated. So in the liver, the conjugated, which is the water soluble, is taken back into the bile duct. The conjugated bilirubin taken into the bile duct, where it is always then again broken down into the bile duct along the bile, along the small intestine, where it is again broken down to be eliminated as urobilinogen or staphylinogen. Staphylinogen in the fecal matter, but you find that most of the urobilinogen are reabsorbed taken back into the system, where they are again going to be released, or they are going to be filtered in the kidney and eliminated in urine. So the presence of urobilinogen and bilinogen is an indication of one, there is the increased hemolysis of red blood cells. 2, there could be an indication with the liver disease or hepatocellular. Liver disease or hepatocellular. So that is about the bilirubin, indication of hemolysis or liver disease or hepatocellular. Then the last part of it, which is the microscope part of it, we are going to check on the presence of cells, and again we are going to check if there are casts. We are going to check if there are we have cells that can have parasites or bacteria. And that is the interpretation of urinalysis. Thank you.